Example 3, filling a tank. A water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. If the water is being pumped out in the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. So the best thing we need to do right now is to draw a picture of a circular cone. Okay, so if we have a circular cone, okay, what do we know about the circular cone? Well, we know two things. We know that the height of this circular cone is 4 meters. Okay, and then we also know that the radius is 2 meters. Okay, now we also then, in the second part, we know that water is being pumped into the tank at a rate of 2 cubic meters per minute. So that means that we have water that's going to be filled up here. Okay, so here is the water, and then there is sort of where the water is. Okay, and what do we know about that? We know that the water is 3 meters deep, which means that the height here for the water, so we can say the height for the water is 3 meters deep. Okay, and then there's a radius here. So the radius for how high the water is, we don't know what that is. But we can see that we get similar triangles. Okay, so here we have a similar triangle, and then we also have another similar triangle here. Okay, so what we can say in order to figure out what R is in step 2, we can use the ratios and write them as a proportion. So we know that if we write radius to height, and that is for the entire circular cone, and we're going to set that equal to the water, which has a radius and a height as well. But again, we're looking for R here, so we're going to fill in the information. So we know that the radius for the cone is 2, and we know that the height for the circular cone is 4. And then that's going to equal R, since we don't know what R is, but we do know the height of the water. And the height of the water is 3 meters. So what we can do here is we can cross multiply and then solve for R. So we have 4 times R, which is 4R. And we have 2 times 3, which is 6. Divide both sides by 4 and reduce, then we know that the radius for the water is going to be 3 over 2. So now what we need to do is we need to find out what is the derivative of R with respect to t. So if we're using the cone, we know that the cone is 2 over R. We want to find the rate. Sorry, not 2 over 4. Because the radius is 2 and the height is 4. Okay, now if we want to find the rate, we need to write this as R over H, and then we're going to cross multiply. So when we cross multiply, we're going to get 4R, which is equal to 2H. Okay, and so from here, we're going to solve for R. So when we solve for R and divide by 4, we get 1/2 H. Okay, now we're going to take the derivative of R and H with respect to T. So if we take the derivative of R with respect to T, we're going to get dr over dt. And then if we take the derivative of H with respect to T, then we're going to get 1/2 times dH over dt. So what does that tell us? Well, now we're going to be able to write down all the given information that we need. We know that the radius that we found for the water is 3/2. We know that the rate of dr over dt is going to equal 1/2 times dH over dt. Okay, and what else do we know? Well, we know that the water is being pumped into the tank at a rate of 2 cubic meters. So if that is cubic meters, okay, that is with respect to the volume. So dV over dt is going to equal 2. And we also know the height of the water, which is 3 meters. So we're going to use this information in step 5 for the volume of a circular cone. Now, the volume of the circular cone is equal to 1/3 times pi r squared h. And what we want to do is we want to take the derivative of this function with respect to t. So on the left-hand side, when we take the derivative of v, we get dv over dt. And then this is going to equal the following. Well, we're going to take the derivative, and we have two variables that we need to focus on, r and h. And since it's a product, then we need to use the product rule. So the first thing we're going to do is we're going to take the derivative of r. So taking a derivative with r with respect to t, well, that means we're going to take 2 and multiply it by 2/3, or 1/3, and so we get 2/3 pi r h, and that's going to be times dr over dt. And then plus, now we're going to take the derivative of h with respect to t. So we're going to get 1/3 pi r squared, and that's times dH over dt. So our goal is we want to find the rate at which the water level is rising. And so this represents the water level that we're looking for. So we're looking for dH over dt. And we know all the other information. We know that dV over dt is equal to 2. And that's equal to 2/3 times pi times r. We know that r is 3/2. Times h, which we know is 3. Times dr over dt, which we know in part 4 there is 1/2 times dH over dt. Plus, we have 1/3 times pi times the radius squared, which we know is 3/2. Square that times dH over dt. Now let's go ahead and simplify anything that we can simplify. Well, we know that this 2 and that 2 simplifies. We know this 3 and that 3 simplifies. And so then also we know that this becomes, so let's see here, 3/2 squared Okay, it gives us 9/4. So what do we know about that? When we multiply that out, we're going to be able to simplify. So let's go ahead and do that. So we have 2, which is equal to, this is 3 times 1/2, which is 3/2, and that's pi, times dh over dt, plus we can simplify that a little further. So we know that this 3 goes into 9 3 times. So we have pi times 3/4. So we have 3/4 pi times dh over dt. Now, if we wanted to then just kind of make it easier on us and multiply everything by 4, we can do that. So let's multiply every term by 4, which is the common denominator. So we know 4 times 2 is going to give us 8. We know 4 times 3 is 12, divided by 2 is going to give us 6 pi times dh over dt, plus 4 times 3 is 12, divided by 4 is going to give us 3 pi times dh over dt. And now what we can do is we can combine these two terms. So we get 8, which is equal to 9 pi times dh over dt. And now we're going to divide both sides by 9 pi. So we can say that dh over dt is going to equal 8 over 9 pi. And so therefore that's going to be 8 over 9 pi meters per minute. So therefore, the rate at which the water level is rising when the water is 3 meters deep is 8 over 9 pi meters per minute. Or if we wanted to simplify this a little further, it would be approximately, rounded to 2 decimal places, 0.28 meters per minute.